Hi, good evening. So this is so I think no part. Okay, so okay. Hi, good evening. So this is parallel session two, and this is ICPM 2020 parallel session two, and first paper is optimal sizing of trigeneration plant integrated with total site system considering multi period and energy losses. So by Khairul Khairul Adzmi and others. Okay, so can you please play the video?
Assalamualaikum and a very good morning everyone. My name is Ken Nazimi Jamaluddin. I'm from UTM University Technology Malaysia, and as for today I'm going to present to you our research, which is the optimal sizing of a trigeneration plant integrated with total site system considering multi-period and energy losses. So as a start, the rising of annual CO2 emission, depletion of fossil fuel reserve, increasing of climate change, and also increasing in energy usage has led the world to find alternative solution to overcome this problem. So one of the solution is to use the conventional power plant and integrate it with trigeneration system. Why? Because conventional power plant use only 30 to 40% of total thermal energy, and the rest of energy is dissipated to the surrounding. This asserted by Kamis et al. 2013. What is trigenerating system? So trigenerating system, or we call it as trigen system, is actually a system that can enable to produce three simultaneous energy from a single fuel input. So this figure shows energy flow of traditional supply mode and also trigen system. So in A, the traditional supply mode, it consists of three different production of electricity, heating and also cooling, and the total input is required 148 to produce at the same energy as trigen system. So as you can see in the trigen system, in B, the fuel input is only required 100, and also to produce the same energy, and also the energy losses is much lower. This is because the energy loss is actually being reused to produce cooling and also heating energy. So by stated by Al-Mosawi et al. 2016, the total thermal efficiency can be improved up to 90% through the use of trigen system. So the second pain that we're facing is the waste heat from the industry. So the figure shows useful and losses energy in industrial plant. So as stated by Pablo Romero et al. In 2019, estimation of 20 to 50% of energy use is actually lost during industrial processes. So one of the problems that we can overcome, that is the reuse of total site system. So figure shows a total site system with integration of centralized cooling system. So what is total site system? Total site system is actually a technology that enables to integrate intra-processes of power, heating and cooling at multiple sites. So as an example, as you can see in the figure, the process A do have boiler to supply additional fuel. So additional fuel meaning that we can supply additional energy. So the additional energy can be supplied to the header, and of course the header will be supplied to the other processes such as process B, process C, and also district cooling that have less energy or energy required by the processes. So if the total still required energy, boiler 1, boiler 2, and also absorption chiller will supply the extra energy to the header and will supply or distribute to the other processes. So through the use of the trigen system, and also total site system. Total site cooling, heating and power is produced. So the figures show the power plant as a trigen system in the total site system, meaning that at the upper part of the system is a trigen system and the below part is a total site system. So actually the total site system will be reused at first to determine the sharing or exchanging the utilities between the different plants, and if the total industry still require energy, the trigen system will supply the extra energy to the header and will be supplied to the industry plants. So the problem statement: the first, rising energy prices, fossil fuel depletion and environmental pollution have increased the needs to find improved efficiency of current energy system. Secondly, conventional power plant only constitute 30 to 40% of overall thermal energy to generate power, and the rest of it is dissipated to the surrounding. And the waste actually can be reused again to perform other application, in this case, heating and cooling, and the reusable can improve the overall thermal efficiency of the power plant itself. And the total site can be reduced the waste heat from the industry by exchanging the utility between the industrial plants. And the intermittency from the demands in tree application can greatly affect the power plant performance, because the application should be continuously produced to meet the demand requirement. And the previous study does not consider the energy losses due to the transmission system. So the objective of this research is to develop a modified trigen system cascade analysis by considering energy losses due to transmission and also storage system, as well as multi-period energy demands to optimize the sizing centralized trigen system utilities. So in this methodology, we propose 6 steps. The first step is the data extraction. So in data extraction, we actually require 3 parts. The first part is to determine power rating and time, and second is to determine the heating and cooling stream data, and lastly, we need to determine the energy losses data during transmission. The second step is the time slice identification. Time slice is actually being used to separate the energy variation within time interval. And the third step is the use of PTA, problem table algorithm. So PTA is used to obtain the temperature pinch point and also to obtain the minimum external heat and also cold energy required. And the fourth step is the multiple utility problem table algorithm. So multiple utility PTA is used to identify pockets and also the target the exact amount of utilities required within a given utility temperature interval. And the fifth step is to the use of total site problem table algorithm. So total site PTA is actually used to determine the amount of utility which is exchanged the utility among the processes. And lastly, the sixth step is to the use of trigen system cascade analysis. So the trigen system cascade analysis is used to target the minimum power heat and cooling, as well as to optimize the sizing of utility in trigen system. So as a result, we can see that the optimal trigen with transmission required more energy required, and also equivalent annual cost and sizing of utility much higher as compared with total trigen without transmission. So as a conclusion, a modified numerical method based on pinch analysis called trigen system cascade analysis by considering transmission and storage energy losses have been developed to determine the exact value of required energy by the centralized trigen system to supply to the demand. And the energy losses due to frictional in transmission, as well as charging and discharging of energy into and out of this storage system are considered. And also comparison have been made with the same case study of the trigenation system without considering transmission energy loss. And the result shows that additional 3 megawatt or 0.1% of energy is required by the Trigen system to supply sufficient energy to meet the demands. And the Trigen also will give an optimal utility size in the Trigen system by reduce the energy differences between the final and also initial energy value in the Trigen system. So as an endorsement, the author, we would like to thank UTM and the Ministry of Higher Education of Malaysia for the financial support under SLAB, Scheme Latihan Akademi Putra, and also several research university fund. And also the authors would also acknowledge the EC project, which is funded by the Operational Program Research Development Education of the Czech Ministry of Education, Youth and Sport by European Union, with the collaboration agreement with UTM. So thank you.
Hey, thank you for the presentation. So,
Thank you.
any questions from attendees? So I don't find any questions in the live chat also. Okay, so okay, I'll ask one question. So what about waste heat generation? So the efficiencies of what kind of efficiencies are you considering for waste heat generation?
The efficiency is considered the thermal efficiency, meaning the overall efficiency that is being produced, meaning that the useful energy has been divided to the total energy at times 300. So meaning that the efficiency is the useful energy that's being used.
Okay, so approximate numbers, any kind of numbers you can give us
Oh,
to feel about it? Yeah.
uh, from my studies, it's around 70% to 80%.
Okay.
From 30%, it can be rise up to 70 to 80%.
Okay. 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 Good. Any questions from the audience? So okay. So I think no questions for you. So I don't find any questions on the chart also. So I think yeah.
All right. So thank you so
So
much,
it's a good
Dr.
work, and so thank you for presenting here.
Thank you so
So
much. Okay.
all the best.
Okay.
Okay, so Dr. Chai. So next presentation is about so development of alpha Fe2O3. So TiO2. So PPODM mixed matrix membrane for CO2 and CH4 separation. This is presenting by Yun Ki Yap. So Yun Ki Yap is around. Okay, so yeah. So can you please?
Good day
Yeah.
to the audience. My name is Yunki from University Technology Petronas. The title of my paper is A Development of Composite Alpha Iron Oxide Titanium Dioxide Filler in PPODM Polymer Mixed Matrix Membrane for CO2-CH4 gas separation. To begin, human population continues to rise along the years, increasing the energy demand. Among the widely used energy are fossil fuels, with natural gas gaining traction due to its cleaner properties. However, the major contaminant that is extracted along is CO2, known to corrode pipelines, has no calorific value, increased transportation costs, and has to be removed to meet pipeline specifications. One of the popular technologies used to separate CO2 from CH4 is membrane, categorized into organic and inorganic counterparts, with both their advantages and disadvantages. Mixed matrix membrane incorporates the advantages of both types by incorporating inorganic filler, which is responsible for gas performances, into organic polymer for ease of fabrication. However, fillers face agglomeration in mixed matrix membrane, Dispersion and agglomeration of fillers is an issue, and one of the ways that may improve the dispersion is by using rotational magnetic field, RMF, to manipulate the dispersion of filler in mixed matrix membrane. When fillers are subjected to RMF, they move as a unit. As frequency increases, they separate from each other. Figure 5 shows the applied forces on the particles. Coulomb's force F is acting between the two particles, and fluid resistance Fl is acting in opposite direction from rotational direction. Because fluid resistance and Coulomb's force are acting perpendicular to each other, we need to consider another force acting in opposite direction of fluid resistance. Therefore, we assume this force as static friction force Fs on contacting surface between the two particles. In the case that the fluid resistance Fl becomes larger than the static friction force, the agglomerated particles can be isolated because shearing force acts on the particles' contact surface and each particle rotates independently as a single magnetic material. As you can see in figure 6, it has already been separated. So moving on, alpha iron oxide was selected to be coated on TiO2 due to its paramagnetic nature, as we want to avoid the filler from agglomerating in nature. As for TiO2, it is a cheaper substrate to test our hypothesis. As you can see, the OH functional groups also promotes the CO2 affinity. So we have two problems and objective here. So the problem statement is, magnetic field dispersion direction is usually conducted only in a single direction. Secondly, there is a lack of quantitative analysis and correlation between agglomeration or dispersion and gas separation performances. So for our objective, we want to elucidate the effects of rotational magnetic field towards direction towards the dispersion in MMM development. We also want to evaluate the dispersion of magnetic nanocomposite particles using qualitative and quantitative dispersion analysis and investigate its effect towards MMM gas separation performance. So here we are in the materials and methodology. So here is the fabrication of magnetic filter. Firstly, we put in TiO2 and iron chloride hexahydrate into a Teflon lined autoclave. And then we will heat it up at 90 degrees Celsius for 5 hours, wash with ethanol and deionized water, and dry in the vacuum oven for 12 hours. Next, we move on to the fabrication of pristine membrane and MMM. Firstly, we will sonicate the filler that is inside the dope solution, and then later we will slowly dissolve the polymer for 24 hours at a temperature of 60 degrees Celsius, whereby we dissolve the PPODM into chloroform solvent. And then we will degas the dope solution in order to remove the gas bubbles for 4 hours minimum and leave it standing for the bubbles to rise up. And then in the end, we will dry cast it using a casting blade and let it evaporate and dry in the vacuum oven for 52 hours. So next, you can see the table 1, which is the design of experiment. We have 5 sets of samples right here. And MM0 is the pristine one whereby there is no magnetic field. So 135 represents the 3 different weight loading that we included into our incorporate the filler into the membrane. So MM3A represents that this same filler loading of 3 weight percent of the filler. After casting it, we will subject it into a rotational magnetic field. So here is how it looks like when we subject the membrane under the influence of rotational magnetic field, whereby the magnetic field is generated by the Helmholtz coil, and we control the power and the frequency used by using a function generator. So the setting is a 32 kHz frequency at 5 minutes with a power of 10 Gauss for the magnetic field. So here's the gas permeation test strip schematics, whereby we're going to test it at room temperature at 3.5 bar. So moving on, how do we do the quantitative analysis of filler dispersion? Firstly, we will use Olympus Stream, which is software, and we will use the optical microscope to capture the image. Then the image will be transferred into the software, whereby we will use a manual or automatic threshold for particle detection. Then we will select the region of interest on the picture, use the application which is count and measure, and then we will classify according to the set particle size and obtain their area fraction and object count of particle. So here's the result and discussion. Firstly, for SEM imaging, we have 5 pictures here representing all the 5 samples. We can see that there are more visible agglomerates with increasing filler contact. But however, just from a surface visualization from SEM, we need a more robust approach to measure the dispersion and cannot judge it using our eyes. Hence, we take a sample, we capture the sample using OM, and then we subject it into the methodology that we have described just now. So we can see here, there are red dot and green dots, whereby the red dot represents the dispersed filler, and the green dot represents the agglomerated fillers. So based on table 2, we can see that at MMM 1, 3, and 5, you can see the dispersion and agglomerates. So we can see that the dispersion, the highest dispersion or the tiny dispersed fillers belongs to MMM3, which is like MMM with 3 weight percent filler. You can see that it is at 38.19% compared to the other two at 36.36 and 4.59. Also, it has a higher relative object count, which means more particle detected at 82.31. So using the best weight percent of the filler that is incorporated, we then subject it under the influence of rotational magnetic field. So we can see that there is an increase in the amount of the dispersion, the dispersed fillers. You can see that the dispersed fillers has increased from 38% to 65.85%. And also, the relative object count increased a lot as well. So then we know that the MMM3A has the smallest particle that is dispersed when compared to the other three samples. Then we'll move on to the gas separation performance. So you can see here from 0, 1, 3, and 5, you can see that the agglomeration of the iron oxide and titanium dioxide filler, they reduce the permeability and selectivity. After putting the filler inside, we can see like as we increase the filler, we can see that the permeability of both CO2 and CH4 drops as we increase from 1 to 3 to 5. So, but we know that MMM3 displays the MMM3, it has the highest selectivity before rotational magnetic field application. After we use this sample and subject it under the influence of rotational magnetic field, the selectivity increased again up to 4.35. So we can say that the rotational magnetic field was successful in effectively dispersing or improve the dispersion of the agglomerated fillers within the mixed matrix membrane after casting on the glass plate. So in conclusion, we know that the MMM showed an improvement of gas permeation performance as compared to pristine PPO-DM membrane. So we know that the MMM casted in presence of rotational magnetic field, it enhances the dispersibility of fillers and break down the agglomeration. It also reduces the cluster size. So we can see that there's a slight improvement of gas separation performance after subjecting it to a rotational magnetic field. So we deduce that this rotational magnetic field application could also be applicable to various other magnetic filler and polymer combination. And that's all from my presentation. Thank you very much. So here are the references used in this, and here's the acknowledgement. We'd like to thank the Ministry of Higher Education for their funding, and also the CO2 Research Center, and the Fundamental Applied Science Department, and also the EE Department from UTB. So yeah, thank you for your kind attention.
Hi, Yunki. So thank you for the presentation. So let us see any questions from the audience. So any questions from the audience? So yeah, any questions? Okay, I'll check in the chat. I don't find any. Okay, so nothing on the discussion forum. Presenter chat is nothing. So okay, okay. So okay. Thank you for your presentation. So I have one question. So can you, how the dispersion of these nanoparticles affect the overall efficiency? Is there any correlation for that?
Okay. Basically, there is not really a significant direct correlation, I would say, because firstly, it depends on the nature of the particles as well, whether the nanoparticles does the nanofiller itself, the chemical properties or physical properties, affect the separation or the efficiency of the gas performance. So, but however, in my case, basically what I observe is upon having the application of the magnetic field. So what happens is we see a better dispersion. However, what we also notice is the permeability decrease as well. Although the selectivity increased, but the permeability decreased. So what we infer from the result of our experiment is Like whenever particles are more finely dispersed, this could possibly create more tortuosity. So end up that the permeability of the gas would be reduced because once the particles are much more dispersed, so the gas has to go through a more difficult and a tortuous pathway in order to permeate through the membrane. So in this case, based on the kinetic, the diameter of the particle itself. So in the end, the permeability will eventually reduce, but also resulting in a much more selective membrane. So I would say the correlation, I think it differs from the combination of your magnetic particles and your choice of membrane as well. So in order to find this out more, I think more studies should be done on like various combinations or various parameters that can be tailored in this kind of concept itself.
Okay. Okay. So, okay. One more question. So let us. Okay. One more question. So, if something like if you try to stabilize with some other stabilizers, so how it will affect your membrane?
Stabilizers. May I know like what are like the example of stabilizers? Do you mean like something that made the particles like not sediment or something like that?
Yeah. Yeah.
I
So
believe that if oh yes, sure, yeah.
yeah, yeah. Go ahead. Go ahead. So there are some stabilizers, like uh, coating on the nanoparticles, or some kind of uh, what to say, kind of surfactants.
Basically, if let's say there is an addition of a surfactant or any kind of coating, I would also say it actually depends on what kind of coating it is. So, because from what we learn from like there's also like various type of coating like functionalization. There's like a physical
Yeah.
functionalization and like chemical functionalization. So I believe that certain coating might help to enhance the and improve the interfacial adhesion between the particle and the membrane itself. But well, what I am not really clear itself is like, will this kind of surface coating, although stabilizing the whole mix filler in the membrane itself, will it also the uh, affect the performance of the magnetic application, such as like because from what I studied in my literature, if let's say the particle size is a bit kind of large, it is a bit harder to say that the magnetic effects towards the particle itself wouldn't be that strong. So if let's say there is a barrier between the magnetic particle itself, like maybe it might not the magnetic field might not help to disperse more evenly. But on the other good hand, um, the surface coating has been proven a great way to help to improve the dispersion and to also help in preventing the agglomeration as well. So definitely, to find out more about this, more studies have to be conducted to compare like side by side, which is the better option.
Okay. 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 One more question.
Yeah, sure, sure.
Okay. So is there an optimum particle size, or
Optimum
is even smaller is better? So is there you need to do you have any optimum size, or the smaller is the better?
This one I would that currently I have not carried out in tailoring the particle size, but from what I've read in multiple literature, in terms of manipulating the movement of the particle itself using magnetic field, especially when it comes to like a dynamic magnetic field instead of a constant one, the smaller it is, the better it is because for the magnetic particle itself, they contain the certain magnetic field of their own. So if let's say for in order to move the magnetic particle itself, there are a few various ways to sort of uh, um, like place an action towards the particle itself. And one of the ways is called like the Brownian motion. So in essence, what we learn in like the normal Brownian motion of gas and whatnot is like the random motion. So Brownian motion also occurs um, in the particle itself. Not to say the motion, but they call it the Brownian relaxation time, whereby because a particle, imagine a particle, you have a north pole and a south pole itself. So it depends on whatever magnetic field that you are subjecting it to. You can actually manipulate the particle. So the smaller the particle, the easier it is for you to control the rotational motion of the particle itself. So whenever the particles are smaller, they have something called the Brownian relaxation time. So a smaller
Okay.
particle has a smaller Brownian relaxation time. So what happens when they have what does it mean by a Brownian relaxation time? So theoretically, Brownian relaxation time refers to the movement of the time taken for the poles of the particle itself to switch. Let's say this south pole and north pole. So maybe it says the Brownian relaxation time is 5 seconds when you subject to this magnetic field. So after 5 seconds, what happens is it will try to align itself to the current field that you are subjecting it to. So the smaller the particle, the Brownian relaxation time of the particle also gets shorter. So when it's shorter, it shows that when you subject it, it has a higher tendency or higher possibility to be rotated and match the current subjecting uh, application of the magnetic field. But in this case, if we are using a dynamic magnetic field, which is like a rotational one, because the magnetic field is always switching in terms of the frequency, it's best to get a particle that is as small as possible in order to reduce the Brownian rotational time and also in hopes to see a better effects. A lot of these can be observed from the studies in other fields, such as the biomedical field, whereby they use this concept in order to break down the cancer tumor. So, because they do not want to do an invasive procedure, so they do a non-invasive procedure whereby they subject the magnetic particles towards a tumor or cancerous site,
Okay.
subject the rotational magnetic field into which has a smaller rotational time or whatnot. So the particle will have a motion and it heats up and end up it will damage and in hopes to kill the cancerous cell.
Okay. Okay. I think we are exceeding time, so thank you for the so good information. So it's a good work. So I appreciate this and thank you. Thank you. So
Okay, welcome. Thank you.
thank you. Hey, okay. So our next presenter is so Amin Abbasi. So he's going to present about conversion of palm oil to new sulfur-based polymer by inverse vulcanization. Okay.
Hello, my name is Amin Abbasi and I'm going to present our study which title is Conversion of Polymer to New Sulfur-Based Polymer by Inverse Vulcanization. Well, nowadays the rapid technological development have resulted in an ever-increasing dependency on the polymers, on the petroleum-based polymers, which is causing serious challenges to both human life and environment. And we know that biopolymers have shown promising potential to replace petro-based polymers. And among these biopolymers, vegetable oils in particular are an abundant and cheap class of materials that have shown great potential to replace these petroleum-based polymers in several applications. Palm oil, in particular, is a readily available vegetable oil in Malaysia and Indonesia, and these two countries produce about 86% of the world's palm oil annual production. And therefore, finding a new application of high interest to overcome the declining demand for this cheap vegetable oil can help to develop the domestic palm oil industry. There are already some investigations on the polymers based on palm oil. However, these polymers had some problems, mainly, let's say, the low conversion, also the necessity to use some catalysts or also initiators. The idea of using palm oil to produce green polymers was motivated by the presence of these unsaturated portion of triglycerides. A typical composition of palm oil it can be seen in this table. Although I have to mention that these can vary with different palm oil species and also based on the growing conditions of the vegetable. Oleic, linoleic, and linoleic acid are the most important unsaturated fatty acid constituents, and almost 50% of palm oil is made of molecules with CC double bonds. inverse vulcanization, which was first reported and introduced in 2013 by Payun, is a technique that makes it practical to copolymerize sulfur with one or more vinylic monomers. It can be monovinylic, divinylic, or multivinylic monomer without the need of catalysts and initiators. This is the advantage of inverse vulcanization, or even solvents. Therefore, the objective of this study is to copolymerize sulfur with palm oil via inverse vulcanization and to characterize the newly developed bio-based sulfur polymer. The materials that we use is just the cheap elemental sulfur and the refined polymer that can be purchased from any supermarket in Malaysia. The ratios that we chose, this is sulfur to polymer ratios. It's 100, 0, 50, 50, 60, 40, 70, 30, and 80, 20. The preliminary results show that the polymers made by sulfur contents higher than 80% are not firm against depolymerization point time, resulting in the conversion of sulfur chains, the polymeric sulfur chains, back to elemental sulfur. To do the polymerization in each selected percent composition, elemental sulfur was first melted by continuous heating from room temperature to 170 degrees Celsius in a glass vial with a thermostatic oil bath and using continuous stirring. After we see a color change in the molten sulfur from yellow to light orange, which shows the initiation of the ring opening process, the palm oil is slowly added to the glass vial to actually to make sure that there is no sudden temperature drop in the glass vial. The mixture was kept for 1 hour at 170 degrees Celsius under continuous stirring, and after the reaction was completed, the samples were cooled at room temperature to obtain the sulfur-based polymer. I also have to mention that range of reaction times and temperatures were initially screened and concluded that 170 degrees Celsius and 1 hour are the best conditions to obtain visually uniform polymers as this one. And the obtained polymers are going to be characterized, or going to be evaluated by FTR, DSC, and TGA. Here we have the TGA thermograms for all the palm oil polymers, and also this table provides information on the experimental and calculated sulfur contents from these TGA curves. The first weight loss, this first weight loss trend or step, can be attributed to the actual sulfur content in the polymers or in the products. This first weight loss percentage increased with increasing the initial sulfur content from 50-50 to 80-20. The ratio of the actual sulfur content over the initially added sulfur load or added sulfur percentage is considered as an indicator of sulfur conversion compared to that of palm oil conversion. This ratio of higher than 1 in the case of the 50-50 polymer shows that a big portion of the unsaturated section of palm oil has not taken part in the polymerization process and was wasted with a sludgy phase that is formed on top of the product. However, in the case of the other polymers, it can be seen that by increasing the initial sulfur load from 60-40 to 80-20, the conversion of sulfur decreased compared to that of palm oil. And according to literature, the onset of the first degradation step of elemental sulfur happens at 210 degrees Celsius. However, these steps actually is taking place sooner for 70-30 and 80-20, and a little bit later for 50-50 and 60-40. The physical properties of the poly-S palm oil. They showed the brownish color that grew lighter by rising the initial sulfur load, and they demonstrated no solubility in the conventional organic solvents such as toluene, chloroform, and phosphorodiazine. The products resulted in a homogeneous phase, forming a rubbery polymer, and we saw that by increasing the sulfur load, polymers showed more solid-like behavior. And poly-S palm oil 7030 was selected for further characterizations. Here we can see the FTR spectra for palm oil and S palm oil. According to literature, palm oil spectrum is very similar to other vegetable oils because all the vegetable oils have actually the same fatty acids, although this the percentages is different. in the case of palm oil, we can see a vinylic CCS stretching peak at 1655 and also a vinylic CH at 3006. And both of these peaks cannot be observed in the case of the polymer, suggesting that all the vinylic bonds are actually reacted and in the polymer structure. Also, these very small peak at 965 in the case of the polymer is due to the CH vibrations in the vicinity of CH bond. All these features confirm the consumption of the CC double bonds of triangular cells reacted with the sulfur chains. The thermal properties of the palm oil, according to literature, the unreacted metal sulfur peaks are at 109 and 119. But here, also in the case of fresh polysulfur and S-palmol 7030, we can see these peaks, which indicates that some of the sulfur has not reacted into the polymer structure or reacted and depolymerized after some time. But the small temperature shift of the peaks confirm that a copolymer actually has formed. We can also see no glass transition temperature in the temperature range because the polymers are very rubbery at room temperature, so we guess that these TG might be below minus 50 degrees Celsius. And also we cannot see any crystallization or melting peaks related to the copolymer, not the sulfur, suggesting an amorphous structure for the copolymer. Conclusion: palm oil was copolymerized with elemental sulfur via inverse vulcanization. TGA was used to determine the ratio of actual sulfur content in the polymers on the initial sulfur loading. Most of the initial sulfur content reacted into the polymer structure. FTR confirmed the formation of the polymer structure and the consumption of the vinyl groups. S-palm oil showed thermal stability up to 200 degrees Celsius for 7030 and 8020, and 230 degrees Celsius for 5050 and 6040. The amorphous structure of the polyester palm oil was suggested by DSC, and no glass transition temperature observed for the copolymer. DSC confirmed the presence of some unreacted or depolymerized elemental sulfur in the product. And finally, due to their environmental friendly nature and low price, S-palm oil can act as a replacement for petroleum-based polymers in several applications, such as, let's say, heavy metal removal or insulation, or even slow-release fertilizers. And these are the references that I actually used in this presentation slide. And thank you so much for your time. And also thank UTP for organizing this conference. Thank you so much.
Hey,
Okay.
Thank you, Mr. Ramin Abbasi.
Thank you very much.
Okay, so there is a question from Dr. Chai from discussion forum. So I don't know whether he can able to speak or not, but okay, I'll read the question for you.
Of course.
So on behalf of Dr. Chai, so I have a question to Amin. So does the carbon chain length affect the final results? So I see that you do not use palmic acid in your presentation.
Of course, palmitic acid cannot react in inverse vulcanization polymer, first of all, because we need vinylic monomers. So palmitic acid, I believe it's 18-0. If I'm CD ratio of palmitic acid is 18-0. So we need this at least a monovinylic monomer to react in the inverse vulcanization polymer, unless we're going to need some catalyst or even solvents to proceed with this reaction. And I don't believe in the case of vegetable oils, because I imagine, except for olive oil, which has a different type of structure, all the vegetable oils have this oleic acid, linoleic acid, and linoleic acid, all of them. The unsaturated section I'm talking about, not the saturated part. So based on the percent composition of these three fatty acids, okay, oleic acid has 1 CC double bond, the linoleic has 2, and linoleic has 3. Okay, for example, if linolenic with 3 vinylic bonds is more than the others, we are going to have a very cross-linked thermostatic polymer. But in this case, oleic acid consists about 40%, linoleic 10%, and linolenic about just less than 1%. So we're going to have a very linear, slightly cross-linked polymer. So I don't think that the carbon chain length have that much of an effect on the properties of the final polymer.
Okay, thank you. And any last question from the audience? So we have, I think, 4 plus 7 audience here. So any question? Okay, so okay, I'll check the discussion forum again. Okay, thank you. Yeah, thank you. Thank you for submitting paper to ICPM.
Thank you very much for your time.
Thank you. Wish you all the
Thank
best.
you. Thank you very much. Thanks, everyone.
Okay, so our next presenter today is Miss Ruwaida. She is going to talk about viscosity and ionic conductivity of imidazation based ionic liquids bearing trioiodide ion. Sorry, anion. Okay, so Dr. Chai, please, can you please play the video?
Assalamualaikum and good day everyone. My name is Raida Ashikin Abu Talib from University Technology Petronas Malaysia, and today I'm going to present my research paper entitled Viscosity and Ionic Conductivity of Imidazolium-based Ionic Liquids Bearing Triiodide and Ion. This is the presentation outline. I will start with introduction, followed by materials and method, characterization, results and discussion, followed by conclusion, and lastly, list of references. Ionic liquid is an ideal material for various energy applications, such as for capacitor, dye-sensitized solar cell, and batteries. Ionic liquid property like negligible vapor pressure, high thermal stability, non-flammability, wide electrochemical window makes them suitable to replace conventional electrolyte. Comprehensive data such as transport property data available on imidazole-based ionic liquid makes them easier to be incorporated into various applications. In the SSC, it is common to find imidazole iodide-based ionic liquid added with iodine to form iodide or triiodide redox couple. Unlike iodide-based ionic liquid, the triiodide-based ionic liquid are lack of reporting of their transport properties, although they are having an equal influence on the overall viscosity and ionic conductivity of electrolyte. Hence, in this study, 3-alkyl methyl imidazole iodide with variety length of alkyl chain of propyl, butyl, and pentyl were synthesized and become precursor to obtain 3-triiodide-based ionic liquid. These ionic liquids then were characterized using proton NMR, and their transport properties such as viscosity and ionic conductivity were explored. This study is hoped to shed light on the suitability of triiodide-based ionic liquid to be incorporated into different energy applications. For the synthesis of iodide and triiodide-based ionic liquid, firstly, we reacted 1-methyl-imidazolium with iodopropane, iodobutane, or iodopentane in acetonitrile at room temperature for 18 hours to obtain 1-propyl 3-methyl-imidazole iodide, 1-butyl 3-methyl-imidazolium iodide, and 1-pentyl 3-methyl-imidazolium iodide. These iodide-based ionic liquid were then reacted with equivalent amount of iodine in acetonitrile at room temperature for 48 hours to obtain 1-propyl 3-methyl-imidazole triiodide, 1-butyl 3-methyl-imidazole triiodide, and 1-pentyl 3-methyl-imidazole iodide. So the iodide and triiodide-based ionic liquid were obtained in a percentage yield of 88 to 90% and 96 to 98% respectively. All iodide-based ionic liquid presents as viscous yellow liquid, whereas all triiodide-based ionic liquid presents as black liquid. So all the synthesized ionic liquid were subjected to structural elucidation using proton NMR, viscosity measurement using Anton-Pah viscometer, ionic conductivity measurement using Wonatec WIS-10 electrochemical impedance spectrometer. This is the proton NMR spectrum for pymium triiodide, propyl methyl imidazole triiodide, and this is the proton NMR spectrum for propyl methyl imidazolium iodide. So all proton NMR spectroscopy confirm the structure and the purity of all synthesized ionic liquid. The formation of triiodide-based ionic liquid from the iodide-based ionic liquid causes a variation in the position of the resonances. The integration of the protons in both spectra of pymium iodide and PMIM triiodide is the same, except that some of the signals are shifted slightly towards the outfield area. The singlet at 9.19, 7.81, 7.74 ppm attributed to the aromatic protons of imidazolium moiety or PMIM iodide shifted upfield to 9.09, 7.75, and 7.69 in PMIM triiodide. Proton at A, B, C are the most affected by the formation of triiodide anion due to its position as acidic proton. The increase of the atomic radius of the anion after the formation of triiodide ionic liquid promotes a greater charge distribution on the surface of anion triiodide, making it to be less electronegative. Hence, the Coulombic interaction in between the cation and ion becomes weaker, the protons of the cation become shielded, and the resonances move slightly towards lower chemical shift, as we can observe in this spectrum of PMIM triiodide. This is the graph of viscosity of iodide and triiodide-based ionic liquid as a function of temperature, where the viscosity is measured in the range of 293 to 363 Kelvin. The triiodide-based ionic liquid showed significant decrease in viscosity difference from iodide-based ionic liquid. The formation of less electronegative triiodide anion has weakened the Coulombic attraction that holds the anion and cation together, hence lowering the viscosity. The intermolecular forces that determine the viscosity of ionic liquid are highly affected by the temperature. So as we can see here, the higher the temperature, the lower the viscosity. Another trend that can be observed is that the longer the alkyl chain, the higher the viscosity as a result of higher van der Waals attraction. So as we can see, PMIM iodide is having higher viscosity compared to BMIM iodide and PMIM iodide. This is the summary of ionic conductivity data of iodide and triiodide-based ionic liquid. As we can see that if we refer back to the viscosity data, the higher the viscosity, the lower the ionic conductivity. So for example, the PMIM iodide are having high viscosity, hence the ionic conductivity is low. When the anion was changed from iodide to triiodide, a drastic increment in ionic conductivity was observed. For example, the ionic conductivity of PMIM triiodide is found to be 15-fold greater than PMIM iodide. So all triiodide-based ionic liquid are having low viscosity as well as high ionic conductivity compared to iodide-based ionic liquid. So in conclusion, three iodide-based imidazole ionic liquid, namely PMIM iodide, BMIM iodide, and PMIM iodide, were synthesized and acted as precursors to obtain three triiodide-based imidazole ionic liquid, PMIM triiodide, BMIM triiodide, and PMIM triiodide respectively. Proton and NMR show that the resonances in triiodide-based ionic liquid shifted slightly upfield compared to their precursor, albeit the integration of the signals are the same. This is due to the greater charge distribution on the surface of an ion, making it to be less electronegative. It has drastically altered the transport properties of triiodide-based ionic liquid compared to their iodide precursor. It was found that triiodide anion has effectively resulting in the formation of ionic liquid of low viscosity with high ionic conductivity. This is a list of references. With that, I thank you.
Hi, thank you. Thank you for the presentation. So let us see the questions from the floor. Okay. Any questions from the attendees? Okay, so I'll check on the board. Okay, so no questions. Okay, so one question from me. So what are which conditions are favorable? So which one, what you want to ionic liquid want to make, like less viscous, high viscous, conductive? So which conditions are favorable for any application?
So in my case, my application is a dye-sensitized solar cell. So I incorporate ionic liquid as the electrolyte for that solar cell. So the key feature that I'm looking for to serve as the electrolyte for my solar cell is low viscosity with high ionic conductivity. That is why I'm studying how to make the ionic liquid to have a low viscosity with a high ionic conductivity feature.
Okay.
Yeah, because it's improving the transport property. In the AC itself, we actually, for the AC, the principle behind it is the electrolyte serve as a medium, and also the medium for regeneration of the dye inside the sandwich of the solar cell. So with a better transport property of the electrolyte, it will enhance the efficiency of the cell.
Okay.
Because it's the ion conductivity is better if it has a better transport property. Yeah.
Okay, so there are a few questions from the presenter chat. Okay, Dr. Chai is asking you one question. So what are the possible applications of iodide-based ionic liquids? What are the possible applications of iodide-based ionic liquids?
Oh, like I said, DSC, dye-sensitized solar cell, electrolyte, as an electrolyte. Yeah. I specifically use iodide and triiodide because actually iodide and triiodide is the classical choice for as to serve as electrolyte in DSC, because they are a pair actually. It's from iodide to triiodide, triiodide to iodide. So it's the process itself, reaction is what do you call, interchange of electron. So the electron is used to regenerate oxidized form of dye. Yeah.
Okay. Yeah. Okay, so your work is interesting. So hope to see this work goes to application. So okay, one more question, I guess. Wait for a second. So I'll check the board. Okay. One question from Dr. Madhya. So is it possible to prepare iodide-based ionic liquids that are liquid at room temperature?
Yes. It mainly, there are several factors that are affecting how the ionic liquid, the final state of the ionic liquid at room temperature. So in this case, the selection of the cation and an ion plays important role. So we need to select the combination of cation and an ion that will give the ionic liquid as a liquid at room temperature. So the selection of an ion and cation is very important. Is it possible? Yes, it's possible.
Okay. Okay, so okay, thank you. Thank you, Ms. Vaida. Thank you. All the best.
Okay, thank you.
Yeah. Yeah, Dr. Chai. So next, okay, our next presenter is so Ms. Salfa Mohammed from University Technology Petronas. So she's going to present about computational studies of ionic liquids as a co-catalyst for CO2 electrochemical reduction to produce syngas using Cosmos RS.
Hello everyone, my name is Shulaf Abdelmajid, PhD student from Chemical Engineering Department under Dr. Wansari Research Group. This paper is about computational study of ionic liquid as co-catalyst for CO2 electrochemical reduction reaction to produce syngas using Cosmos RS. This will be the outline of the presentation. Let's start with introduction. CO2 emission harmfully affects the environment. This technology tries to utilize CO2 using renewable source of energy and electrochemical reduction reaction to produce chemical fuel so that we can close this cycle. Electrochemical cell mainly consist of anode, where the oxidation reaction of water take place, and also cathode where CO2 electrochemical reduction reaction take place, separated by nephew membranes that only allows the hydrogen ion to come from anode side to the cathode side to prevent products in the cathode side from reoxidation. Here, this is the cyclic voltammetry. The main challenges associated with this technology is first selectivity. because during CO2 electrochemical reduction reaction, many products form. To find catalysts that targeted a specific product is an issue. Also, to find a stable electrolyte for so long time also a problem. CO2 is highly stable, which means it requires too much energy, and this is also a problem. The current density usually low. So to find a catalytic system that can avoid all these limitations together is a real challenge. Moreover, the mechanism behind the reaction is still a big question. So in this study, we try to understand the catalytic roles of ionic liquid in CO2 electrochemical reduction reaction through computational method. We use thermomol to generate homo-LUMO value. We use Cosmo RS also to generate sigma profile and hydrogen bond interaction, misfit interaction, and van der Waals interaction. We support this study using Rosing and Vasiliev experimental data. The LUMO value from experimental data were calculated through this equation. Vasiliev in his study, he studied different structure of cation, mainly pyrazonium based. The difference is in the number of alkane and also the position. He used TFSI as anion. Rosen in his study, he used MM as cation and PF4 as anion. So in our study, we use all this structure. So we neglect the effect of anion since the cation have been reported as a more active part in this process. From sigma profile, from minus 0.01 to the left side, this region is for hydrogen donation property, and from 0.01 to the right side, this is for hydrogen acceptance properties. In between, it is for non-polarity part. So we can see that all this structure have high ability to donate hydrogen. So here we zoom the profile to see the order of the different structure. We realize that the order of the structure, starting from the highest ability to donate hydrogen to the lowest, same order that been reported by Vasiliev in terms of the catalytic performance. So for more clarification, we study the hydrogen bond interaction and also van der Waals and misfit interaction through Cosmo RS. We realize that the order of hydrogen bond starting from the highest to the lowest is the same order of the catalytic performance starting from the highest to the lowest reported by Vasiliev, and also the same order from sigma profile in terms of the ability of hydrogen to donate hydrogen starting from the highest to the lowest. This negative sign here indicate an attraction force. We also study the LUMO value of the different structure. We realize that the LUMO value starting from the lowest to the highest value, it takes the same order of the catalytic performance reported by Vasiliev. So for more validity, we also calculate the experimental data, and we realize that the order also same between the computational study and the experimental data, but there is deviation in terms of value, and this deviation because in the experimental data they use acetonitrile as solvent, so it's not purely ionic liquid. So Vasiliev assumes that the activity comes from the interaction between CO2 intermediate and pyrazonium ring positively charged region. So from our study, it can be concluded that the LUMO value also might affect the activity of the ionic liquid, since LUMO value indicate the ability to accept electron, which is also the reduction reaction, so it makes sense. Also, we try to make correlation between the LUMO value and hydrogen bond. We realize there is a strong linearity between them with R square value 0.9985. So, for more validity to this hypothesis, we took another example done by Rosen. He studied the effect of Icpeam Ps2 as electrolyte for CO2 electrochemical reduction reaction. After that, he add also 18% of water. So he reported that the addition of water enhance the catalytic performance. So we study the hydrogen bond interaction and other misfit interaction. So to see the effect of addition of water, we realize that as the addition of water increase the hydrogen bond interaction energy. So the conclusion of this presentation, first we use Cosmo-RS and Terpomol to highlight the effect of molecular interaction, mainly hydrogen bond and also LUMO value. Also from this studies there is new hypothesis being highlighted. The LUMO value can be the reason behind the activity. Also strong linearity is obtained between hydrogen bond interaction and LUMO value. These are the references. Thank you. Hello everyone.
Hi, thank you, Ms. Alpha. So, thank you for the presentation. So, this is about computational study, right?
Yes.
Okay, so a question for you from the audience. So, Dr. Moniruzaman. Okay, so I'll read the question for you. So
Yes.
it is shown that deviation between Cosmo RS results and experimental results are high. What is the reason for it?
I mentioned in the presentation that in the real data, they used cetonitrile as a solvent. Actually, mainly I want to highlight that the order are same. But because they use acetonitrile as a solvent, so it's not purely ionic liquid, but the order of the activity same from the experimental data and from the computational study. I can see the other question is to prepare effective catalyst, which cation or anion play important role. According to the previous studies, they highlight that the cation play the main role because it's positive and it's reduction reaction, so it's more close to the electron. But inshallah, during the study, we realized that both has direct or indirect, but mainly the cation has the highest effect. Thank you for the question.
Yeah, one more question, Dr. Chai. So, okay, is it if you carried out any study on energy requirement? So, is there any kind of study carried out on energy requirement for the CO2 reduction process? So, if so, what is the how it vary? Is it very energy incentive?
Any study? Just wait. Let me see the question. You mean experimentally? Because I can.
Yeah.
Yes, experimentally, I'm actually in this phase. Mainly yes, because we can from reduction reaction we can convert and calculate LUMO value. according to the equations that I already provide in the presentation. Also, through thermodynamics, yes, already people calculate, but there is deviation also from the reality. Because this area actually had a lot of things to work on it, because even recently the concept of homo-lumu value itself, it's many people still do very conflicting, they have many conflicting results on it, but it's really interesting area.
Okay, you mean it is reduction? Okay, CO2 reduction is like how much? Like what you say? Comment on the how much energy intensive?
Actually, theoretically, it should be minus 1.9 volt.
Okay. Okay, so interesting study. Okay, so
Thank you.
thank you.
So
Thank
the
you.
objective is to reduce actually the potential applied.
Okay.
Okay, thank you.
Thank you. Thank you. So all the best for your further study. Thank you.
Thank you.
So our next presenter is hey, here is something different. Oh, okay. So So our next presenter is Dr. Shafiq. So from oh, okay. So but affiliation is UTP. But okay. Okay, our next presenter is Dr. Shafiq, and he's going to present on about fundamental studies on etiopropylene removal from model oil using toluene assisted ionic liquids. Okay, so Dr. Chai, can you load the presentation video?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Hazim Hamzlan, and for today I'll be presenting on fundamental studies on etiopropylene removal from model oil using toluene assisted ionic liquid. So for Icpeam 2020 in conjunction for ESCON 2020. So in my presentation, I will be looking into introduction and also some literature review for my study, and also objective and scope for this particular research, some methodology on how I collect the data, some result and discussions on the data collected, conclusion, and also some acknowledgement for this particular project. So introduction to heavy oil, a little bit of introduction to heavy oil. The world supply for crude oil is actually continuously depleting due to great demand driven by dramatic globalization and also industrial growth. A recent report by BP predicted that the world conventional oil supply will only exist for 53.3 years. Thus, this one opens up a possibility for us to try to adventure into unconventional oil resources. And recently, the unconventional oils such as heavy oil and also extra heavy oil being converted to a new fraction of alternative is actually highly desirable. However, the production cost of heavy oil or extra heavy oil is actually higher compared to the conventional oil due to its contaminant and also viscosity. As you can see from the world energy demands, oil maintained as the main contributor of the energy in the world. And also if we look into our oil reserve, heavy oil reserve, we have another 433.8 billion barrel of oil, and most of it is situated in South America. So if we look into heavy oil properties and its impurities, normally oil is being graded by its APA index. Those with less than 20 will be graded as heavy oil, and less than 10 will be graded as extra heavy oil. So it is due to its high carbon content, asphaltene, heavy metal, sulfur, nitrogen, as well as low hydrogen to carbon ratio. The composition of heavy oil and concentration of the metals actually greatly depend on the geological formation, location, age, and also field age and depth of the field. And the most abundant undesired heavy metal is actually nickel and vanadium. And this one have to be removed before it be sent to refinery, because it can poison the catalyst and also cause for corrosions.
However, in this case, in heavy oil, the nickel is actually situated inside a metal complex where we call ethioporphyrin in this structure. So it is quite challenging compared to removing just metal. We have to take out all of these components together. So that's the case of this study. So recent methods on demetallization techniques such as ion exchange, salting out separation, electrochemical, microbial demetallization, microwave radiation assisted using chitosan, and also supercritical water has been studied by these researchers. And also, although electrochemical treatment, microwave radiation treatment, and also supercritical water treatment has shown great results in removal efficiency, more than 85% for nickel and also using microwave, and also nickel ethioporphyrin, which is an interest compound, about 90.64% using supercritical water. It uses high energy of for generation of microwave radiation, and also temperature and pressure for supercritical water. So this opens up our new possibilities of using chemical treatment inside our process. So we are proposing to use ionic liquid as a green solvent, which is what we know. Ionic liquid is actually a salt which is liquid in room temperature. Ionic liquid is actually tunable because we can change the cation and anion depending on our component and also our target components. And also it is non-flammable as well as have negligible vapor pressure. So we don't have to worry about our solvent leaving the system through evaporation. So it shows that it is highly regenerable and also have a high thermal stability, and also it can be recycled several times before being regenerated inside the regeneration system. Okay, looking into several research has been conducted for the removal of nickel and also vanadium as a pure components in crude oil sample and also residual samples. So you can see that components such as Icpeam NTF2, ionic liquid such as Icpeam NTF2 has been tested to have about removal percentage of 24% for nickel and 7% for vanadium. And this one plays into our advantage, as this one has already been proven to remove nickel as a pure component, and we are targeting to remove nickel ethioporphyrin as our interest compound. So by then, our objective is actually to remove nickel ethioporphyrin in model oil performed in using liquid extraction process via imidazolone based ionic liquid, which is the first generation of ionic liquid. So our scope is actually for our extraction time, we have 30 to 90 minutes, extraction temperature of 30 to 90 degrees Celsius, and ionic liquid will be using two types of ionic liquid over here, which is Icpeam OS and also Icpeam NTF2. And the screening process for before we get to this ionic liquid will be done using Cosmo RS, while the removal efficiency of NIEP will be done using UV spectrophotometer technique. Okay, looking into our methodology. First, we prepare our 60 ppm of NIEP as our initial concentration for our model oil, and then we construct a calibration curve to determine the concentration of 4 unknown concentration that will test after the extraction process. So we can see that we have two visible bands over here, which is S band and also Q band, whereby our metal complex, which is metal porphyrin, normally being found inside this region. Okay, so around 571 nanometer and 553 nanometer. So after we conducted this testing, and we get the calibration curve of 0.0661x plus 0.038 with coefficient of determination with 0.9981. So looking into our experimental run, since we're looking into liquid-liquid separation, we'll have our extraction time and extraction temperature at minimum of 30, midpoint of 60, and also maximum of 90. We have two ionic liquids being used, as I mentioned earlier, and also we'll have a ratio of 1 to 10. We are using 5 ml of ionic liquid with 50 ml of model oil, which is already being tested the best ratio so far. Okay. So the result will be discussed is effect of ionic liquid towards selectivity, capacity, and performance index using Cosmo RS, the removal efficiency, and also the stability in TGA. So if we're looking into the screening of ionic liquid, you can see that in selectivity, cation that will be tested is actually TBP, tetrabutylphosphonium, BMIM, and also Icpeam. All of this is actually suitable for metal complex due to its non-polar characteristic. However, TVP shows better potential due to symmetry structure where all the outside atoms are the same. So BMIM OS has a broader peak when we study using sigma profile, and it shows that has a lower selectivity compared to all other cation being tested. However, for anion, it shows that NTF2 and OS, octyl sulfate, has peaked in both non-polar and also hydrogen bond acceptor region, and also OS has a broader peak in polar region compared to NTF2. If we look into capacity, TBP perform better compared to BMIM and EMIM because of the hindrance effect by BMIM and EMIM, which have heteroatoms at the opposite direction of the aromatic structure, while TBP doesn't have that, and it causes higher capacity. While in anion, NTF2 perform better compared to OS, MS, and also HS. And we combine it together to become a performance index. You can see that TBP perform the best. However, phosphonium-based liquid is acidic and actually can be thermally reactive. Since we are doing liquid-liquid extraction, we don't want to have any side reaction happening inside the system. So that's why we try to omit this particular TBP as our selected liquid cation. However, for BMIM, we know that from the selectivity, it has a broader peak. So that's why we try to remove this particular component from our system, and then we select with EMIM. While for anion, both OS and also NTF2 shows a greater potential and also can be tested for further testing. So for the NIEP removal efficiency, we can see that EMIM NTF2 was better. EMIM NTF2 is actually better than EMIM OS at any given temperature and pressure, which is it can be seen that metal ion exchange favor a hydrophobic anion, which is in this case NTF2 was better and also have higher hydrophobicity. This is because of ionic liquid with NTF2 and ion is less likely to be dissociated compared to ionic liquid with OS and ion. So means that it has lower hydrophobicity. So it can be seen from these results. Okay. However, this trend is actually more stagnant, almost stagnant, as the temperature and the extraction time increase due to NTF2 has actually reached its maximum capacity. So it doesn't have any further increase. So it's already being stagnant all over here because it's already achieving its maximum capacity. And also for the stability, you can see that the ionic liquid used is actually very stable at the temperature which is less than 100 over here. It can go even higher, more than 300, because it's less than about 245. 300 already started to degrade. You can see over here. So actually, this rule out the concern for degradation of the solvent. As for conclusion, you can see that EMIM NTF2 shows a better selectivity, capacity, and also performance index during the screening in COSMO-RS. With its own argument, EMIM NTF2 shows promising performance as it is able to extract more than 20% of NIEP from the model oil. Okay, and also optimization in this case it is not possible since the trend is not visible and it's already approached the asymptotic NIEP removal for using EMIM NTF2. So as recommendation, it is suggested that to increase the range of the operating temperature at higher condition, since it already been stable at around 200 degrees C. Why not we try to go higher? Maybe tested some other conditions such as subcritical condition for the liquid. Then it's suggested also to study the mass transfer modeling on the extraction process to increase our understanding of the process. Okay, so I would like also to acknowledge these researchers already been assisting me in doing this research, and also YTP for providing the grant for it. So with that, I'd like to say thank you. Assalamualaikum.
Okay, so some questions from the audience. Dr. Moniruzaman, seems that both the hydrophobic and hydrophilic ionic liquids can extract Ni from oil. So what is the mechanism of this extraction? So
thank you, Dr. Rajasheka. How are you? On addressing Dr. Munir Zaman, in this part we already conducted some FTIR study, and it shows that there is no side reaction happening inside the process. The reaction we propose that the separation is actually following a liquid extraction processes. So based on the affinity of the component towards the ionic liquid, it doesn't have any temporary bond on the ionic liquid itself. That is to address the thermonism concern.
Okay, so you mean it doesn't matter like hydrophobic or hydrophilic?
Because right now, since that the component itself, the NIEP is actually quite hydrophobic because it is soluble in oil. But since there is a charge being attached to the any liquid, the probability of OS and also the octisulfate and also NTF2 both are able to extract this component. But looking at the safety side of it, NTF2 is actually highly toxic compared to octisulfate. But in this study, looking at NIEP as the main component, we are choosing NTF2. But if you're looking at high capacity and performance, then we'll be looking into Icpeam OS.
Okay, thank you. So, another question from Dr. Madhya. So, is there any other potential applications other than nickel extraction?
Thank you, Dr. Madhya. So currently, actually, this study is being conducted to two different metal and four different metal component. Porphyrin group. We have ethioporphyrin and also tetraphenyl porphyrin. So this is actually specifically to extract the heavy metal complex inside the heavy oil. But we need to understand that metal exists as a form of metal complex inside the asphaltene group inside your heavy oil. So instead of extracting the metal itself, we extract the complex together so that it can be isolated directly and also reduce the viscosity of the heavy oil. Then it will increase up the favorability of the heavy oil going for further processing.
Okay, thank you. So I think something is interesting about this. So yeah, it is. Hopefully, it's we can utilize the heavy oils by these methods.
Sure. Thank you.
Thank you. Thank you. Okay, so our next presenter is it Omar, right? So, but the schedule says something different. Okay, so next presenter is Mr. Omar. He is going to present about pH and electrical conductivity measurements of aqueous solutions of amino acid based ionic. I think something is incomplete. Okay, so he's talking. Okay, so he's going to present about measurements of pH and electrical conductivity of aqueous solutions. Okay. Okay, so Dr. Chai, can you please play the video?
Good day to the respective judges. So this work is done by the gas hydrator research team in the UTP. So I'm going to talk on a pH and electrical conductivity measurement of aqueous solution of amino acid based ionic liquid. So the outline of this presentation is ionic liquid and amino acid based ionic liquid, problem statement, objective, methodology, result and discussion and conclusion, and lastly is reference. So we know that organic, ionic liquid are organic salt that are liquid phase at a moderate room temperature, composed of large asymmetric cation and organic and inorganic anion. They have a negligible vapor pressure, high thermal chemical stability. Anion and cation can be chosen and tailored, high ionic conductivity and non-flammability. These are the basic property of ionic liquids. When it comes to the application, they are importantly applied for separation, catalysis, electrolysis, pharmaceutical, biological uses, chemical engineering uses, solvents, lubricants based on their uh, thermal chemicals, solvation, large electrochemical window, non-volatility, and low melting point and ionic conductivity properties. So we know that the toxicity of ionic liquid is the main obstacle that limit the potential commercial application. In 2005, Fukumoto, a pioneer in preparation of amino acid based ionic liquid, he prepared the amino based ionic liquid by simply combining the 1 ethyl 3 imidazolium cation with the different amino acids. They are in 20 number, and this amino acid based ionic liquid, simply I can call AAILS, consists of amino acid utilized as either anion and cation in combination with other ionic liquid cation and anion. So AAIL are liquid at room temperature with the ability to enhance a biological activity due to their biodegradability. So the advantage of AAILs is that they have two reactive functional group. One is carboxyl group and another one is amine group, motivating their application in several fields such as bulk chemical processing of CO2 capture, chiral catalysis, and peptide synthesis. So, in order, to effectively use AAILS as either a solvent or for a CO2 separation, their basic characteristic must therefore be well studied and understood. So, pH and electrical conductivity play a pivotal role in a chemical process. So in order to attain our problem statement, so we have a two objective. One is to measure the pH and another one is to measure the electrical conductivity of a equation of AAILS. So these are the three chemicals that we use for the following study. Number one is a 1-octyl 3-methyl imidazolium glycine, alanines, and proline. So these these three chemicals is prepared with a four different concentration: 1, 10, 20 weight percent, 30 weight percent. So we these are the two equipment that we use for pH and conductivity measurement. So the molar conductivity, you know, the electrical conductivity results are divided by the molarity to get the molar conductivity as shown in the equation. So looking at the first parameter and first objective is pH, we find that uh, we find that OMIM proline is shown is more pH behavior, alkaline behavior as compared to the glycine and alanines. As we know that OMIMAA dissolve in a water, it will be analyzed in their cation or anions. As the amino acid is negatively charged, it will attract the hydrogen of the water molecule and produce more OH in the solution. The cation OMIM positive does not form a strong hydrogen bond with the OH due to the long alkyl chain, which increase its steric hindrance and the hydrophobicity. So from above the graph, it is concluded that AA is responsive for the pH of the solution. This finding is further confirmed by the comparing the pKb value of the AA and the studied AAIL. It is well known that the smaller the value of pKb, higher the value of Kb and the stronger the base. Okay, so this table is telling the value. So now the next parameter that we have a electrical conductivity, but we find that glycine shows a higher electrical conductivity as compared to alanines and prolines. So AAILS increase the charges carrier concentration, hence the electrical conductivity increase as compared to the water. In addition, the electrical conductivity of the OMIM glycine in aqueous solution represented highest conductivity, as I told, as compared to the alanines and prolines. So from these two parameters and all the result and the measurement, these physical-chemical properties, what we conclude that all the AAILS solution shows the alkaline nature, OMIM proline shows the highest pH value, and the amino acid present as an anion in AALS found to be the controlling factor in the pH value. The conductivity measurement influenced by the types of the amino acid. So what we find, OMIM glycine has the highest conductivity due to its smaller size and the molecular weight. Increasing the concentration result in increasing the number of ions, hence the electrical conductivity increase. So with this, I will say thank you and ask for the question answers. Okay, thank you so much.
Uh, yes, Doctor. Actually, my student is supposed to, but he cannot get in. He has a problem with the voice. Yes, Doctor, please.
Thank you for your presentation. So I will ask questions from the audience. Okay, audience, any questions? So okay, questions from the audience. Okay, so Dr. Lam is asking about how about the recycle use of ionic liquid in this study?
How we recycle the? Sorry.
Yeah, recycle use. So how?
The ionic liquid, actually, this one is what we call this recycling the ionic liquid.
Yeah.
We try to explore the physicochemical property. Recycling, I think we have not covered this one generally. Yeah. Does it mean that how can we recycle? That's what that Lam is asking.
Yeah. So what is the possibility of recycle?
Recycling, because we have not done any test in the reactor, regeneration type system. So we just try to figure out the physicochemical property. Yes, we can do recycling with amino ionic liquids, but that was not the focus of this study.
So can you elaborate of application of this? So any kind of
Actually, Dr. Raz, basically we try to see these two parameter pH and electric conductivity related to the promotion. The promotion that we can use for amino acid for separation or desalination properties. So we find that this pH and conductivity play important role to enhance, to see the enhanced factor that when we talking about the rate of hydrogen formation. So that's what we find out. Because if we're looking at the pH, that our actually, by the way, this is not ionic liquid. They are amino acid based ionic liquids. So the most of the role played by glycine, alanines, and prolines. That's what we wanted to see. Yes.
Hey, okay. Sorry, previous question was not for you from Dr. Lam, so it is for Dr. Shafiq. I'm sorry.
No problem. No problem.
So one more question for you. So Dr. Moniruzaman, so what are the purposes to measure pH and electric conductivity of amino-based ILs?
I think I already explained.
About toxicity and how it is related to toxicity. Like you want some your opinion about it?
The toxicity, I think this is the most important parameter that need to be studied, but we have not explored. We just wanted to concentrate on these two physical chemical property, because the toxicity we need to do beneficiary or other tests. We haven't done that, so we just focus on the physical chemical property to see that how this alkyl chain and the anion and cation playing an important role in hydrogen formation. So that's why we just do only two properties as an assessment.
Okay, so hopefully your ionic liquid will be useful for those applications.
Yes, at least publication. Okay.
Thank you for the presentation, and Thank you for participating in ICPM.
Okay. Thank you for having me, Doctor. Thank you so much. I think it's the last presentation. I think you guys done a wonderful job. Thank you so much.
So I think you are the last one. So any more questions? Final questions from the audience? Okay. So thank you all. So thank you for so this session, and Dr. Chai is very much helpful too. So to conducting. Okay, all credit goes to Dr. Chai and Madiha for standby, and Dr. Azizul for all of his arrangement. And thank you very much.
Welcome, Doctor. Thank you. Thank you.
Thank you. Thank you. I think we can end this session. Thank you.